Hello and welcome. In the last two videos, we took a first look at shape-based matching and how to process the results of the matching. In this video, we will take a look at some advanced parameters that might help you if your application doesn't find all matches, for example because they are blurred or deformed. Additionally, we will discuss how to speed up your matching. First, we want to take a look at a parameter that deals with a basic functionality of shape-based matching, num levels. Internally, shape-based matching works with image pyramids. This means that the size of both the image and the model are reduced repeatedly. The search for matches is first performed in the low-resolution image, which is very fast. Based on the result, the search area is limited in the following pyramid level. Thus, the model doesn't have to be searched in the complete image, saving time. In Create Shape Model, num levels specifies how many image pyramid levels are created. If it is set to auto, the number of levels is determined automatically based on the size of the object. In Find Shape Model, you can either limit the pyramid levels further, or you can set it to 0 to use all levels that were created with Create Shape Model. Using the operator Inspect Shape Model, you can get a good impression of the pyramid levels. If num levels is chosen too high, some matches may be lost because they couldn't be recognized in a low-resolution image. On the other hand, if you begin the search on a lower pyramid level, it may take a long time because of the high resolution. Alternatively, you can skip these lower levels in the search by passing a tuple like 4, 2. Now, your search begins in the fourth pyramid level and ends in the second level. Thus, you can improve the runtime of your application. The accuracy, however, might decrease. Sometimes images are of poor quality, for example because they're blurred. Thus, your matches might not be found at the lowest pyramid level because the edges are not clear enough. Nevertheless, the edge information may be sufficient on higher pyramid levels. In num levels, we can pass the tuple 4 minus 2. The minus in front of the 2 activates the increased tolerance mode, which means that if no instance of the model can be found on this pyramid level, HDevelop determines the lowest pyramid level on which at least one instance of the model can be found. Thus, matches which are blurred can be found. If the shape-based matching can't find all matches, one reason might be that the objects are slightly deformed, like these paper clips. Using the parameter subpixel, you can specify how much a match might be deformed in pixels. This can be really powerful, but it may increase runtime. In many applications, you might consider using an image with a reduced domain as the input image for Find Shape Model. For example, here we have an object on an irregular background. We're trying to find this cross. When running Find Shape Model as usual, we notice that it takes a long time to run because the size of the model is quite small in relation to the size of the image. This means that few pyramid levels can be used. Additionally, false matches are found. Instead, we can do a simple thresholding and then some blob analysis. From here, we can reduce the domain of the image so that we only search the part of the image where the object is located. In sum, the time required for these operations is much lower. Additionally, like in this example, you might be able to avoid false matches with this method. You may have noticed that the region of interest is really small. The matches don't have to lie completely in the region of interest. It is enough if the center of gravity of the original model is inside the region of interest. Next, let's have a look at the parameter metric used in the operator Create Shape Model. The standard value is Use Polarity, which means that if your object is bright and the background is dark, only objects which are bright on a dark background will be found. With Ignore Global Polarity, you can additionally find all matches where the object is dark and the background is bright as well. This has only a small impact on runtime. Finally, with Ignore Local Polarity, it's possible to find matches where the contrast changes locally. This mode can be really helpful if you have to deal with illumination changes, but it increases runtime. There are many additional parameters you might want to take a look at to improve the performance of your application. For example, in Find Shape Model, greediness can be used to tweak the runtime. Lastly, there are additional operators like Create Scaled Shape Model and Find Scaled Shape Model if you deal with matches that may vary in size. As you see, shape-based matching is a very powerful tool. If you have additional questions, have a look at Halcon's extensive documentation, including the solution guide on matching. Check out our YouTube channel for more tutorials and information about our products. Thank you for watching.